Welcome back. Esteemed colleagues, welcome back. Sir's presentation is there. Sir's presentation is there.
Yeah, I know. Ma'am, you have to move a little bit aside because I will control.
So we'll now move on to the next session on presentations by the delegates. For the first presentation, we have Dr. V.S. Prasad, Head, National Center for Medium Range Weather Forecasting, NCMRWF, Ministry of Earth Sciences, India. Dr. Prasad's key areas of expertise are data assimilation, data reception, data processing. He has made critical contributions to the development of operational deterministic IMD GFS as well as ensemble prediction systems, IMD GEFS systems, which are now central to IMD's operational forecasting. He was instrumental in integrating Indian satellite and other data into NCOM and EPS frameworks, establishing the NOAA and EU Medcast data reception infrastructure at NCMRWF, processing and sharing of Indian direct broadcast data with global community. He pioneered the first indigenous Indian global reanalysis system, which was done for 20 years of reanalysis. His research significantly enriched the understanding of the Indian monsoon, tropical cyclones, and the impact of various observational systems on global weather prediction systems. I now invite Dr. V.S. Prasad to make his presentation on celebrating 30 years of numerical weather prediction.
Welcome back to scientific session, and the earlier session also we discussed about presented about the 30 years journey of NWP in NCMRWF, and now I elaborate and also present what is our future course of action and that one. And I start with it. My outline of the talk will be the brief background of NWP and advance of model development in the 3 decades and the computing infrastructure and progress in observation processing and data assimilation, and next what is the applications of that one and also vision of the future products. See, India NWP, when it started that in 1950s in elsewhere, the Richardson experiment and von Neumann and also that computer things. At the same time in India also the efforts were started, NWP. In IMD, Dr. Datta and Dr. P.K. Das was initiated the NWP thing, and Dr. R.K. Bansal and Chabri Mukherjee, they worked that one, and Dr. Bansal later he joined here and data assimilation, data processing. He was the instrumental the first OA and data assimilation thing. And the same time in IITM also, if you that one the efforts were started in IITM, the efforts were different. IITM invited Professor Takeo Murakami and trained the people in the NWP, and if I agree that Dr. S.K. Mishra and Brahmananda Rao Garu and Professor Vitlamurthy and all that people and also all that people were trained in that one, and so India was not lacked at initiating the NWP in the beginning. We are also that one, and in the IMD that quasi barotropic model and was initiated, and 4-layer QG models were there, and data assimilation things also started Sinha 1972. So that indigenous efforts at NWP was initiated in the way back in 1950 things all, but the operational system, the full system was not. Efforts are indigenous efforts are also going on, and the breakthrough comes in when NCMRWF established. The people scattered in IITM, IIT Delhi, and IMD. All the people were brought together under the umbrella of NCMRWF, and the highest level, the Prime Minister of India and President of USA, they brought the system of Cray here and established the system. And on 25th March 1989, the first HPC was inaugurated, and the aim of it is sort of the project. to give the agriculture forecast, to improve the forecast for the, especially for North Indian region where the forecasts are driven by the western disturbances. So that system was established with T80 thing and operationalized that one. As said earlier, 1st June 1994, IMD accepted the charts. And the mission of the NCMRWF is continuously to develop the NWP models and demonstrate the new novel applications and maintaining the highest level of knowledge and skill and expertise. With this vision, under Ministry of Earth Sciences, now under the guidance of Professor Dr. Ravichandran, we are going ahead with the thing. And if you see the journey, in 1994, we established T80 L44 system. And up to 2007, we continued with the same model. As indigenous efforts are made that one. We actually that time, Dr. Swati Basu and Dr. Rajagopal and Harendu Prakash was there, and John, they tried to improve the physics. And also, the efforts are completely to port the system and develop HPC also. Instead of going for the HPC from the outside, systems from the Department of Atomic Energy and also CDAC systems, where we try to put the system, complete indigenous type of efforts we tried. And we found that by the time we are doing that one, the progress in the elsewhere is very high, very big, because the team in India is small. By the time we have achieved that one, the increase is fast. So in 2007, again under Dr. Rajagopal, I went to NCEP and got the 2T54 model and complete that system. We updated that one. After that, India started working parallelly with UK Met Office, because people found that high rainfalls are not being captured in the GFS system. So parallelly we are going that one. And I work along with myself and with other team, we try to NCEP systems, improving that one, and the parallelly efforts are on by other members to go to the UK Met Office. And we improved our systems rapidly from 385 and 574, and like that in 2015, 12 kilometer 1534 initiated that one. And 2016, system also been in place. And in the 2017, when new system came, the GFS system we call it IMD GFS, and IITM, the system was operational, model development was given to IITM, and the assimilation at NCMRWF, and we started parallelly between IMD GFS and seamless forecasting system. And 2023, we experimentally indigenously developed a 6 kilometer model from the system, and also coupled land ocean atmosphere coupled model with 10 kilometer for NWP. That is also we parallelly tested that one. And this is the evolution of the computers that we are taking. That I told the T254 XMP, we did that one. And parallelly, as I told earlier, that completely efforts are made to do the Indian HPC systems. DEC alpha system from the atomic energy, that is Dr. Bohra and team worked that one, parallelizing that system, the DEC alpha. This system was about 2 years we used this system. Completely the code system, everything was indigenous system with HPC DEC alpha systems. We did that one, and proudly complete Indian indigenous efforts are there in that one. And then we again started with using CDAC Param system, and that also, because Param system, IO of the Param system is not that much, but model processors are good. So we usually create SY even and Param together for the model that thing. And of the formation of Ministry of Earth Sciences, our journey started very quickly. We started updating the system very frequently, and we have the KX1E and IBM Power 6, Bhaskara and Meher. Quickly we update, and now we've gone to the Anurika with the 8.44 petaflops a year and RCAT and CMRWF. This is the timeline that we are going for the assimilation, upgradation of system, and thereby what are the models, resolution also with the increasing the things. T8 at 150 kilometers, the thing. And you can see that 2007, after formation of Ministry of Earth Sciences, very frequently we are updating the HPC systems, and thereby we are able to increase the model and assimilation systems. We achieved this. This is the shows the timeline graphs. And this is one of the first charts to show that one. That time we are using the plotting for visualization. We are using the NCMRWF systems, and data decoding other thing also from the simulations. And the other thing, the government giving the HPC system, and we at NCMRWF we build the data assimilation system, data reception system here. Earlier we are getting only the GTS data, and we made efforts to get the data first from the NOVA PDA. We started the get data, and started putting data other than GTS data, satellite data, other thing. And the other thing with the UMETCAST system, that terrestrial reception system, that is that our NKN and European NER and joined together, we started getting the more data. And with these efforts, NKN and also we are getting the internet era, we started connecting to the all satellite data centers throughout the 10, and we got the more data. So here the data assimilation systems become very strong. We are able to independently add, assimilate many satellite data and handling that one, radiance, radiation, and satellite radiance, that thing we have started using that one. And at the same time, India is the only, is one of the few countries having the satellite program and also NWP system also. We at NCMRWF worked with SAC Ahmedabad to get the all Indian satellite data assimilated in their system, and we are the first team. We are the first thing we are able to do the AMV vectors, height reassignments and correction. That one we are using to improve the satellite wind forecast. And this is the journey how the various satellites are being assimilated. Now INSAT TDS was launched recently. It is completely funded by the MOAS. And we are also Microsat 2B, similar to Megatropics, Saphir. We are getting the data. And NCMRWF shown how the critical the data sets and the quality of the data. So spectrometer and Saphir, Megatropics, these sensors were internationally accepted after the developments done and proven that the sensor quality and the impact of the data. So we are able to do that one. And this is the scheme of the assimilation systems. And when NCMRWF established, Dr. R.K. Bansal, he was doing optimal interpolation that was brought from the IMD. And then we have spectral statistical interpolation, and we have all the assimilation skills. And now we are doing the hybrid 4D war and the 4D ensemble war this with ensemble members. We are doing the very high resolution ensemble assimilation. And the data processing and assimilation, we are leading that one. We are able to handle a lot of data. And when the wind profiler AOLS come, apart from the NCMRWF, NCMRWF is the second system, second operation NWP center to use the AOLS data in real time. This is the first, after UPCMWF, UKMETA is NCMRWF only able to do the operation assimilation. And when we implemented, when we changed to 574, our quality of the forecast was very much improved, and we reported an improvement of, we can see this one also, the clear-cut improvement in the timelines. We around 2010 when we upgraded, when we started using satellite data, more satellite data, and upgraded the system, our forecast quality was very much improved. And 2010, we demonstrated about more than 2 days gain in the forecastings, and that we use it for the reanalysis. So that started the quality of the data, availability of the data, and the model quality are improved. So we started 2010 as a base year for our reanalysis, and the reanalysis things are here. And this is around ensemble system also. Dr. Gopal Iyengar is there. In 1995 itself, that ensemble things, he visited University, USA, and started that 8-member breeding method. Ensembles also we started very early. But around 2012, when the quality of the data was very much improved, and 2012 onwards we started ensemble systems running on real time, and 2015 UTKF method was implemented, and now and around 2018 the 12 kilometers, that time it is highest in the world, that we are able to put high 12 kilometer ensemble system, one of the highest, and this is the where another novel thing also, deterministic and ensemble all at same resolution. Now Metaphase and ECMW are doing that one, and 2012 we are using the same method, that ensemble and as well as the more deterministic are the same resolution at 12 kilometers, and so that also first it started NCMRWF, and we are now doing 60 for seasonal forecasting also. 16-member 60 kilometer ensemble system was also placed, and that also doing very well for the extended and seasonal forecasting systems. And so over 30 years we shown the development of the atmospheric models, and resolutions also we have got the highest resolution models, and integration of ensemble by giving the probabilistic forecast and Earth system with the coupled models. We entered in the coupled Earth system models for NWP things. And this is the regional systems we have now. We started with 50 kilometer regional, now 30 kilometer, 330 meter urban model, Delhi urban model we are doing for forecasting the visibility and the fog over the IGA airport. And with this also, now in momentum partnership, India is leading as for this working group. And in future, what our plan is, we achieved with the 20 petaflop systems available. We are planning to go for K-scale modeling, that is kilometer scale model for convective scale simulation, and also go for coupled NWP, so that we can go attempt for the digital Earth. And also we have the two systems, so statistically processing all the data with AML and also other statistical method to give the bias corrected forecast, so that forecaster can have that one. And also we give the probabilistic forecast, so that forecaster can assess the scale of probability, and also how much dependency to which model to give that one. So we are doing the bias corrections with that things. And coupled model, as I said earlier, now we are using 65 kilometer model for the seasonal sub-seasonal forecast, and we already tested 10 kilometer global model parallelly with that one, and also we are developing 2 kilometer regional coupled model with KPP, and we found that very encouraging results out of that one. And our forecast, this I'm skipping, the forecast quality is almost equivalent to other global models, that is showing that one. And with various applications, as Dr. Parvinder Morning told, that the main, at the time of NCMRWF, it is for the agriculture sector only. They are planning, it is mainly for the agriculture. But from the last few years, we have encountered to giving the lightning forecast, and also we are giving wind energy forecast. And this year, NCMR will become first time revenue earning system. We are getting the wind energy sector. They are paying for our product. This first time this year we implement that one. Similarly, we are giving with CWC, we are working on the flood forecast, and also our sister organization NCC are giving the high flows forecast for the metropolitan cities of Chennai and Bombay, Mumbai, etc. And air quality forecast we are doing, and the fog forecast. So a lot of applications we developed over the years. And as I said, that one, when the forecast qualities are improved, we have we did the reanalysis, one global reanalysis for the using NGFS system, and one IMDA analysis with 12 kilometers. And this is the only system where we have every hour products are available, so that people are studying, and many papers are coming. And I think recent years it is that IMDA paper is the highest reference paper from the MOS things, and we found many people are applying that. Recently, I saw Dr. Ramesh presentation where he shown that IMDA rainfall products are very well agreeing with the rainfall that is observed and the trends observed over South India. And with AWS data also he explained the trends very much. Similarly, Dr. Dadwal used the maximum minimum temperature from the rain analysis and able to show the wheat production changes, trends. And he matched it very well with the maximum minimum temperature of IMDA and the wheat production in the West Bengal, in the thing. So these products are very, very well accepted, and number of users for this one are very more than 3,000 users are using the system, and we are done. That's why we are planning to upgrade, use this system, put it on the cloud so that many users can. Now we are making this data available with a simple server, and we are going for a couple of IMDA server, that cloud server that our secretary inaugurated today. There we want to put that one so that many people can access the system. And for the future also, that AML techniques also we started using the AML techniques. Dr. Amara Jyoti and Praveen is there, they are working on that one. And we have got the bias corrections and as well as the satellite rainfall retrievals, and also heat wave predictions, and also giving the nowcasting of rainfall we are using. And many satellite products also we are using that with the international web page of satellite, we are putting the things. And this is one of the products, DWR rainfall. Every 15 minutes we are retrieving that. This product is made available on website, and clubbing the rainfall observed in the radar as well as satellite and AWS using the AML. We are clubbing together. This product is now every 15 minutes rainfall over the country. And with the Mosam Mission project, more radars are coming. We are able to give trends of this rainfall more accurately at a very small time scale. We are able to give that. And this is our future plans. We are working on the NWP for science and technology. This is the vision for 2047. We are planning that one. And cloud facilities for improving the product diverse applications. Also, we are trying to do and capacity building. And we are working with BIMSTEC countries and RIMES for being the capacity building in our, not only in the country, internationally also we are working on that one. And we are in that sector also working, and we are putting AML in weather prediction. This is our future plans with that. Thank you very much for it.
So if you have a couple of questions. Okay. Yes, sir.
AI and machine learning, some 8 students have used it for their PhD work. I think that one of the most important thing is to properly predict. From the NWP prediction to actual prediction, AI should be used and machine learning should be used, and that's very important. And that, I think, comes as the last subject. I think it should come. AI is becoming too viral now. For every field it is being used. So it should be used in weather forecasting.
With that thing only, we are our reanalysis products we are making available so that we can more rigorously we can yes.
Prasad, it's good to know. Yeah, it's good to know that IMDA is getting very popular, and especially we have to acknowledge the Met Office contribution in that, which was a monsoon mission project which was funded by MOES to Met Office. So it's a real great achievement because we started it way back in 2011, 12, 13, 14. It's really materialized. It's good to know. Make the data available more freely, not going through this channel of registering and all. Some other method you have to adopt.
Yeah.
They make it freely, just like the way NSUB does. Okay.
Okay, sir. Thank you very much, sir. We now move on to the next presentation. The next presentation will be by Dr. Michael R. Farrar, Director, National Centers for Environment Prediction, NCEP, NOAA, USA. As Director NCEP, Dr. Farrar oversees the planning, science and technology, and operational responsibilities related to NCEP's 9 national centers, which include National Hurricane Center, Storm Prediction Center, Weather Prediction Center, Ocean Prediction Center, Climate Prediction Center, Aviation Weather Center, Space Weather Prediction Center, Environmental Modeling Center, and NCEP Central Operations. There are 9 institutes. Earlier to this, Dr. Farad served as Chief Scientist for Weather Operations for U.S. Air Force, Senior Vice President and Chief Operating Officer of the UCAR, University Corporation of Atmospheric Research, Director of EMC, and Director of NWS Meteorological Development Laboratory. He also served as the Acting Deputy Director for NOAA Office of the Ocean and Atmospheric Research. Prior to his work at NOAA, he was Vice President of Strategic and Business Development for Science and Technology Corporation. He served U.S. Air Force for 24 years in several leadership positions in forecast operations, scientific development, program management, training, budgeting, planning, policy, and collaboration with U.S. and international partners. I now invite Dr. Farrar to deliver his talk on collaboration with NCMRWF MOS and future technologies for weather and climate services, advanced Earth system modeling, and emerging trends in data-driven models.
In my notes here, so I don't screw this up. Sorry. There we go. So, welcome. Thank you for having me. As you can tell from my introduction, I have a hard time holding on to a job. I've done many jobs over my career. I really enjoyed them all, but this last one in the government has been very rewarding, working with all the NCEP centers and our international partners. And I'm really happy to be here today to celebrate with you for your 150 years for IMD and, of course, the 30 years for the National Center. So that's the first thing. Congratulations. We have worked really, really well together, particularly over the last 30 years with modeling. Really, we've centered a lot on the global systems with GFS and the GDAS, as well as the climate forecast system and the ensemble. We've had over 10 years of collaboration with HICOM and WaveWatch 3 and HWRF and 12 years of the National Monsoon Mission, and I really want to congratulate you all on your new and exciting RS-2000 mission, 2000 core valued mission for Muslim. That's fantastic. Really looking forward to seeing the output of that. So I'm going to do very briefly, I'm going to go through a little history of how NCEP has collaborated with our partners here in India, and we'll talk a little bit about kind of the state of the systems in the United States to kind of go with what Dr. Prasad said, for how things are going here, and we'll end up with a little bit of future looking. So for GFS and GDAS in 1994, it's kind of also 30 years ago. You acquired our NCEP and GDAS models and started producing your medium range weather forecasts. Lots of improvements were made. Going forward a little bit longer with their ensembles in 2010, we all acquired our GFS, our GEFS model, and then of course later on that decade, working on CFS version 2, which, believe it or not, we're still running operationally. It's been in operations for a long time. I'll talk to you a little bit about our development of our seasonal forecast system, which is our next upgrade at the end of the briefing. So with HWRF, this is really a new implementation that was signed in 2012. You all acquired that and put it into operations in 2014. I understand that Dr. Mohapatra was instrumental in that partnership. Vijay actually said that you're known as Cyclone Man of India, which I think sounds pretty good. It's almost like Superman or Iron Man, but Cyclone Man is a great title. So we thank you for all your collaboration over the years, particularly with HWRF. We've noticed in our country as well, it was extremely important to improving our track and intensity forecast, particularly the intensity forecast, which had languished for many years without a lot of improvements. WaveWatch 3, of course, is an international multi-nation agreement for waves, and of course in 2015 you all acquired that as well. So through all these visits, it's been really mutually beneficial for both our countries, and I really appreciate all the work and collaboration that you all have done with us over the years. So as far as the collaboration on Monsoon, you all are aware, of course, that this started, I think, back during a NOAA-MOES annual bilateral meeting in Delhi that my predecessor or two ago, Dr. Louis Uccellini, attended. And I think the initial idea was proposed by then Director of IETM, Dr. Goswami. That was in 2012, after the implementation of your implementation of CFS v2 for us at NCEP. And the seasonal forecast done there really had the highest skill for the all of the India monsoon that year for February. So a little bit later, that agreement, that implementation agreement, was extended for 5 more years. And of course, you can see the signing ceremony there that did occur. So that just a continuation, success built upon success. And we continued that for many years since then. So a little bit more on HWRF. That was, of course, that was implemented back in, really, by Dr. Vijay Talapragada and Zan Zhang, who are both here today. For EMC in 2010 as part of our implementation agreement on tropical cyclones. They were training IMD modelers back in that time and running HWRF for the North Indian Ocean tropical cyclones. I think also the exchange went the other direction too. I see that IMD also sent several scientists, including Dr. Ananda Das, to our Environmental Modeling Center, or EMC, for training. Under the same time, about 12 well-known hurricane experts from the U.S., including one of my professors from Florida State and VJ's advisor at Florida State, Dr. T.N. Krishnamurti, and several others came and joined us during that, with the support from Dr. Mohanty for here. So that was just a wonderful collaboration. So at that point, we're going to pivot a little bit and look at the modeling system at EMC and NCEP. Believe it or not, this is the simplified flow chart of how our modeling system works. So this is one of the reasons that we are going into a unified system through the unified forecast system, to try to have consistency and ease of implementation and maintenance, to try to bring most of our models into a unified modeling framework. All right. So our goal here, of course, our strategy is unifying the production suite into a consolidated unified modeling system and a framework so that we can use shared components across all these multiple architectures and without compromising on the product delivery and service. And so this is a lot more simplified than the flowchart I showed you a little bit earlier. So we're trying to bring all of these systems into our unified forecast system. We have made lots of progress. There are some of the models, particularly the GFS, that are already operating in this new unified framework. The next one was the Hurricane Analysis and Forecast System, or HAFS, and GEFS and the CFS, now going to be SFS, are coming next. So the future, the global systems here really are going to be implemented, really, I think, through the remaining time frame over the next 4 years, through about 2028. To get us all operating in this unified framework. They're mediated by the CMEPS mediator. We're building for the GFS version 17 and GEFS version 13 a fully 6-way coupled system with the dynamics and the finite volume Q-sphere, FV3, ocean for MOM6, the cryosphere for SICE 6, of course the waves for WaveWatch 3, and the aerosols under GoCart. FY26 is we intend to implement this for the GFS, and then a little bit later in FY27, or maybe a little later, we're hoping, because it takes a long time to do these reforecast reanalyses, for finally our first major upgrade in the seasonal timescale in well over a decade. A lot of work has been done on EMC and our partners across NOAA, so we're really looking forward to sharing that with you when it happens. So our medium-range weather forecast, that's really where her goal is to build a 6-way coupled system, and there has some in prototypes. This is kind of a prototype run that was already developed and tested. So we're really looking forward to bringing that into operation. So we'll talk a little bit more about some of the specific model components. The GFS V17, I'm not going to read all these to you, but I think some of the really important parts are the fact that, for instance, with the data assimilation, we're finally bringing into operations with this model version the JEDI structure that we have been working on with all of our U.S. interagency partners, and I'm really happy to say that we have a new partner like a year or so ago. The UK Met Office is joining us here with this effort, bringing in new physics, much higher resolution, of course the six-way coupling, and we're really, really excited about this, again, coming in a couple of years. So with that, accompanying at that time is also the next version of the Ensemble Forecast System, or GEFS. Similar types of upgrades here, and we're increasing our members. We're taking it out a little bit longer period, out to 48 days, and of course accomplishing this 31-year reforecast, which is one of the reasons that it's waiting until this time frame to do it. Okay. So the impact of the coupling really has really helped us at the MGO. Really, the skill was extended by at least 5 days compared to the old GFS V12. And so we're already seeing for our prototype development a huge improvement through this coupling for our longer range forecast periods. So at the CFS version 1, CFS V2, this is being replaced by the seasonal forecast system. Our goals really, you can read them here, but really we're balancing across all the interfaces. We're looking for really lowering our uncertainties and the best estimation of those uncertainties in the future, and also bringing this into the unified framework so that we can bring in all the physics improvements we're making at the GFS and the GEFS timescales into the climate timescale. One of the other things we're working on is it going to be enabled to run in the cloud, so you can use massive resources when we need to surge and do reanalyses and reforecasts, rather than having to do those on our own systems. And we are actually working through our NOAA partners with the Earth Prediction Innovation Center to help us bring that out to the community. So it's not just inside of NOAA, but our external partners as well. So some of the early results are promising. Really, we're outperforming CMAP style models, especially for the ITZZ, and for ENSO and for other large-scale models of variability on seasonal timescales. We also are avoiding that double ITZZ we've seen in the past. So we're really, really encouraged by this early work, and are really looking forward to bringing this into operations within the next few years. So on to hurricane models. This is one of the reasons we're here this week with the HAFS workshop. This has been a big project which a lot of folks have worked on. Of course, Vijay early on, and of course Avichal has led a lot of this development in his team. This was a very successful implementation a year and a half ago, and we've been using this for the last hurricane season or so. It has shown, even though HWRF and our HMON group our forecasts have done very, very well and have improved our track and intensity forecast over the past. We've seen additional improvements with the implementation of HAFS, and it's really helped our National Hurricane Center provide just world-class and incredible forecast for tropical cyclone development early on. We actually are having state and local officials declare disasters a week out before the storm even develops based on our forecast. This would have been unheard of 10 or even 15 or even 10 years ago. So the improvements that we've made starting with HWRF and now through HAFS has really led to a revolution in the way we do emergency services in the United States by taking much, much earlier action. And the confidence level that we've had with our forecast has really helped us push the envelope out in terms of our forecast period. So significant progress really has been with the latest version of HAFS, which is implemented in July of 2024. You can see just some of the examples here. One of the things to really note, I don't know if you can see my cursor, the forecast and the actual track are literally right on top of each other for a lot of these storms. I like to, sometimes you'll pick the very best cases to show, but these are actually fairly typical of the kind of, particularly with track that we've had with the new HAFS structure. And then most recently, the major hurricanes that impacted us in the United States, Helene and Milton, the same kind of issue with the track. Whoops, goodness gracious. There we go. that we've gone with the track forecast for both of those were extremely accurate in intensity. Rapid intensification, which we were able to project several days out, has really been a game changer for us in the United States. And then looking at some of in your area, with Ramal exactly, very similar type of performance. So we're very happy to be collaborating with you on tropical cyclone forecasting using our new system. All right, so shifting gears a little bit, one last thing with HASS. We're really happy with the workshop that's happening this week. We're here. It's important to us. Several of our EMC scientists have joined. Of course, our partners from CWA in Taiwan also coming. Lots of hands-on training this week. We're really hoping that this is really helping all of us collaboration for years to come. So pivoting now a little bit to the data assimilation. This is something that I've been involved with, believe it or not, since 2001, when I was still in the Air Force as a young major. One of my jobs was to help the Air Force join this consortium for the Joint Center for Satellite Data Assimilation. So over the years, I collaborated both from the Air Force and from NOAA. We're really happy to see that this is finally making its way into operations. But before that, we had the GSI. That's been in operation since 2007, but a lot of that code is really 30 years old as NCMRWF, or sorry, too many letters. But as long as your organization really is our collaboration, the GSI has been there, or parts of it anyway. So reminder, JEDI is a project within the Joint Center for Satellite Data Assimilation. It's not just an infrastructure, but new science and new ways of doing DA, and it's allowing us to really build in multi-model coupling in a very modular way so that we can collaborate between different modeling centers that are using different dynamical models. We can use some of the same core data assimilation software to collaborate. Some of the weakly coupled DA preliminary results for sea surface temperature are shown. We really have been able to dramatically improve our biases as well as our error. Is really a better estimate of the foundation temperature. It really leads to a better simulation of those radiances, which of course are sensitive to sea surface temperatures. I want to move on quickly now we'll talk a little bit about some of the emerging trends. We talked a little bit about machine learning and artificial intelligence. As we pointed out, we've been working on this in modeling world for many years. Of course, now it's exploding, and as you mentioned, it is really taking over a lot of different fields. There's a lot of things here similar to what Prasad showed with the timelines that you all are working on. We've been doing some pieces of this for about the last 30 years, starting with neural networks and making our way out to just recently on doing emulators for some of our model physics. And also, I'll talk a little bit about us taking on some commercial proxy models using Google's GraphCast. So we really once this was released about a couple of years ago, it kind of hit the world out of surprise a little bit. Several companies, not just Google, but Huawei in China and many others, really rapidly was able to, using the Mira 5 reanalysis and reforecast, were able to provide some really astounding large-scale predictions using machine learning. So Vijay, as senior scientist at EMC, as well as the whole team, started experimenting with that. I'll show you a few slides of our experimentations there. We were able to get some really remarkable results in really short order. So one of the things we did was we adopted GraphCast and we modified it using GDAS initial conditions. And then we trained it against not only the Mira 5, but our own GEFS reanalyses and reforecast. We're hoping to, as just an experiment, to make sure we knew how to do it and to operate with it. We're planning to do that once the new version of GEFS is in place, to really expand our use of machine learning and AI to actually create our machine learning and AI-based models similar to what the European Center does. And then just a little bit of a showing of our 500 millibar anomaly correlation charts, comparing it to our GFS and GraphCast. So we have very comparable stuff, I would say, right out of the box. We really didn't do a lot of development, just brought our data in, and we were able to replicate it very quickly. So we do see this as a really good future for us, particularly not just on large-scale proxy modeling, but also creating probably really large ensembles at a very cheap computational, as you all are planning to do yourselves. Interestingly enough, we also did this for tropical cyclone track verification. We're able to really, at least for the larger storms, to show an improvement even over what we're doing with the GFS. Similar with reducing bias in RMSE on the large scale. This is the chart for 2-meter temperatures. There are other products that are very similar. So how does it fit into our future? Or, really up until now, just like Dr. Prasad and others are going to talk about, our NWP forecast came from obviously from dynamical models at NWP. Improvements came from forecast resolution, from improved physics, from improved data assimilation, and the data that goes in. But really, I think these rapid improvements in AI are showing that we're better utilizing our training data sets. We're able to more efficiently bring in these deep learning methods, and we can change our workflows to adopt the new the newer GPU technology, and be able to rapidly produce some of these forecasts. So the predictions of the extremes are still not very good with machine learning. Obviously, we need to be able to construct a representative ensemble, and capturing predictability limits. We're all addressing these problems. One of the things that's not here, but I'll just mention that one of the issues that we're starting to have, and I think the world is going to have, is the demand for machine learning and AI has driven up the cost of data centers and actually reduced the availability of new high-performance computing. So for the last 20 years, our supercomputer, we would go buy a new one, we would lease it at a data center, they would run it for us. Every year we could pay the same amount and get better. Not anymore. The costs are going through the roof because we're competing now with the private sector, who are buying up not only the high performance computing, but also the space in the data center. So it's really going to be a challenge for us. That's something that's really we're confronting now for the first time in a long time. So this is one of the things that, looking at the future, what can we imagine that maybe in the future, we're not sure yet. We're still developing what our plans are going to be. That maybe our operational production suite is really the backbone of a continuously updating, coupled Earth system model, not only for the long range like we've done in the past, but even for the short range. We're not sure, but potential for, especially with the machine learning and AI, making these computations cheaper, being able to bring in a digital twin component. Really, the regular prediction systems, I think, can be coupled then with the outcomes, whether it be for fire, for atmospheric dispersion, for anything else. These post-processing methods really are very linear from output of the model into algorithms. Being able to go to skip the middle step and be able to train these data sets to the outcome, it really provides an interesting future. So there's also how are we going to bring all these together to what's the right blend going to be between the dynamical NWP we're all used to and the counterparts with machine learning. And we're just like you all, we're thinking about how we're going to make best use of cloud performance systems, whether it's in the short range or for the episodic things we do for reanalysis and reforecast. So that's all I have for you today. I really do appreciate being here. Oh, go ahead. Thanks. I do have time for questions. I'll take any of the easy questions. Hard questions go to vj.talapragada@noaa.gov. So anyway, if there's any questions, I'd be happy to take them. Otherwise, we'll go to the next speaker.
Thanks very much for your continued help to India, and I was curious to know how much significance the reanalysis resolution is going to be for training AI models, ML models. Now your NCEP reanalysis is 0.25, so whether that has any role in playing when you go to 12 kilometer, half the resolution, AI models will improve further or not? Thank you.
So you're asking how the resolution of our improved resolution is going to impact I didn't quite understand that last part.
Yeah. Improved resolution of the reanalysis for training AI and
Yeah.
models will have any significant role in the skill of AI focus.
you're getting a little outside my area of expertise, but I can speculate. I do feel it will be an improvement, but creating a high-resolution simulation, and whether or not it verifies with the actual forecast is an issue. So I really feel we have to do a much, much larger ensemble members than we did before, and that's going to drive up the cost. But I think this is where maybe being able to do this, instead of using all the dynamical models that create all these members, we may be able to, if we calibrate it correctly, maybe use a machine learning version that we can create instead of just hundreds, maybe thousands or even millions of members to be able to create that uncertainty. It's what I think, but did I get to your question or close enough? Okay. All right, thank you. Anybody else?
Will you be using AI for ensemble modeling?
Yeah, that's what I was just talking. I believe so. Yes, that was one of the primary purposes we'd like to do.
I'm Colonel Professor Sanjay Srivastava. Thank you for a very good presentation. I just wanted to request you to stress upon building better forecast through community partnership.
Yeah.
How you are involving community and making a better outreach and compliances.
That part I can really, we are, one of the purposes of our unified forecast system was not just to put all of our stuff into one framework, but we're developing it as a community model. So the history of NCEP, for the most part, have been internal development, maybe partnerships with a NOAA laboratory or NCAR, but in the end, it was all internally generated. So we've always had a history of putting our codes out and making them widely available. So that is one way collaborative. We're trying to build a new system where we have the ability for collaborators across the world to make improvements and bring them back into our system so that we can add them to the baseline to benefit everybody. So that's actually the whole concept of our Earth Prediction Innovation Center, or EPIC. It's starting slow. It's a big mission, and it's not funded as well as it should be. So we're really getting the software engineering and code management in place. So our long-term goal, though, is to build this UFS as a community system so that people could contribute to it just like they would WRF or WaveWatch 3. All right, well, thank you all very much. I really appreciate it.
Thank you, sir. The next presentation will be by Dr. Walters, David Walters. He is the Associate Director, Foundation Science UK Met Office UK. So he will be presenting on NCMRWF Met Office 15 plus years of collaboration. Dr. David Walters is the Associate Director, Foundation Science Team. The Foundation Science Team is responsible for developing physical and machine learning modeling frameworks for weather and climate applications. Dr. Walters' core area of expertise is global and regional NWP model development. Previously, Dr. Walters was the head of Research to Operations section, who develop, deliver, coordinate upgrades to the operational NWP systems, responsible for improvements across model components, evaluating new model formulations, diagnosing problems in model performance for NWP. His interests include role of resolution in global atmospheric model performance and extension of short-range NWP forecasts to include increased Earth system complexity. So earlier, he also led the Global Atmospheric Model Development Group that is responsible for developing global configurations of the unified model for use across all weather and climate timescales. I now invite Dr. David Walters.
Thank you very much. Unlike Mike, I think I've had one job over the last 20 years, if you look at it one way or another, which is to try and develop and improve our models, although it's been fairly varied in doing that, as you'll have heard. So I'm going to give a bit of a summary of the last 15 years, actually 16 years of collaboration between the Met Office and NCMRWF. I'm going to start with a bit of background and history into our unified modelling system. I'll then talk about the work that NCMRWF have been doing with us to contribute to the development of that modelling system as part of our Unified Model Partnership. And I'll finish by looking forwards a little bit to the future, to the development of our next generation partnership that we call Momentum. So to start with, so the Met Office is the UK's National Meteorological Service. We're based in Exeter in the southwest of England, and we are essentially responsible for developing and delivering climate and weather prediction and projection data and the production of services and products based on those to the UK government, to the public and to the wider community. And our stated purpose is to help people to make better decisions to stay safe and thrive. So the Met Office was founded in the 1850s, not in a building that looked like this, but we were in a kind of corner of the Board of Trade. It was originally set up like a lot of modelling centres and a lot of weather centres in response to a specific event. So it was set up specifically to try and alleviate the impact of severe storms on shipping and the loss of shipping. But within the first decade, we produced our first public forecast, which was published in the Times of London in 1861. In terms of NWP work, our first work was an experimental forecast run on the Lions Leo computer. So this was a computer that was developed by the Lions Tea Company. It was actually the world's first business computer, and they worked with the developers of EDSAC to bring a computer into their operations in the 1950s to run their payroll and their stock ordering system. And it did that during the days, and then on the weekends and overnight, it was used for research purposes. And one of those purposes was to run a very, very low resolution, 12 by 8 grid point resolution NWP forecast. Our first operational forecast was between 10 and 15 years after that. We had our first global forecast in 1982, and by the late 1980s, we had separate global NWP, regional NWP, and climate models. But when I say separate, they really were separate. There were separate groups developing these, separate groups using them to produce the output. So there was an initiative started in the late 1980s, which was to try and bring these things together. And the original aim of the unified model was to make the development and maintenance of the core code simpler. So the idea was, let's develop one dynamical core, let's develop one set of input and output routines, or one set of physics routines, and then use that to build the models that we need in different applications. So the first applications of the unified model were a global coupled climate model, global NWP, and mesoscale NWP over the UK, with the first operational forecasts coming from the global forecast in 1990. Since then, the unified model's come a long way, and today we use it for a global climate prediction, for seasonal forecasts, global ensemble predictions, global deterministic, convective scale ensemble prediction, convective scale deterministic, and very high resolution urban scale modelling with grid boxes between 100 and 500 metres. But in this time, the development of the unified model and the way that we use it has changed. So rather than being something that we use for computational efficiency or to reduce the development costs, we recognise that by running a model over all of these different applications, studying its characteristics, and then using what we learn in one configuration to inform another, will allow us to produce a better prediction system. So to help with this, we essentially have two science configurations of the unified model. One of these is the global coupled configuration, which is used in all of our global applications with parameterized convection. And the other is our regional atmosphere and land configuration that we run in these very high resolution simulations. And this is developed with our partners in the Unified Model Partnership so that we collectively develop the best science configurations of our model. We test and assess those over the different domains, and we can use what we learn in all of those applications to bring it back into the development of the model itself. So moving on to the Unified Model Partnership. The partnership is something that we started working on in the 2000s. The figure on the left-hand side is the members of the partnership. You're running operational forecasts in, I think this was about 2011, this picture on the left-hand side. But NCMRWF joined the partnership in 2008. And here we have a facsimile of the signature page from the original licensed agreement. And then the update to this in 2016 when NCMRWF became a core member. They've recently joined the Momentum Partnership, which we will talk about later on. And at this stage, Dr. George Pankiewicz, who is the head of our collaboration team, he was previously the manager of the UN Partnership, has asked me to extend his thanks and greetings onto all the former heads of NCMRWF that he's had the pleasure to work with, and also to pass on good wishes from Stuart Bell, who was responsible for managing that activity. To take a slight diversion into a kind of personal contribution to this, so in 2008 to 2010, I was personally developing regional configurations of the UM, and I was developing workflows that allowed these to run with data assimilation in relocatable domains. And in late 2009, early 2010, we had a visit from Dr. Saji Mohandas and Dr. John George, and they came to try and develop the first regional configurations of the UM for use at NCMRWF. And I managed to kind of dig out the domains that they were working on the left-hand side. So yeah, it was kind of a personal remembrance, kind of thinking about this in this meeting, and obviously that was the first time that I met them both, and it was the start of an ongoing friendship. In terms of NCMRWF's contributions, I think somewhere to start is to say that I talked about this development of these global and regional science configurations, and they really are community efforts between all members of the partnership. And one of the first things that a new partner can bring to this is to bring their own expertise into the development and the assessment of our model configurations, and which helps us understand their strengths, sometimes more importantly, understand their weaknesses and work out how we need to improve them. So obviously one of the things that an Indian collaboration with NCMRWF is going to bring us is knowledge and understanding of the Indian monsoon. And this is a figure from some global climate predictions. So these are atmosphere-only climate predictions over a 20-year period, covering, and the results here are averaged over every June, July and August during that period. In the top row, we have a model from 2012, and on the top left panel is the error in this model compared to precipitation observations. On the right-hand side is an error compared to top of atmosphere long-wave radiation compared to observations. And we can see, maybe not surprisingly, as we see in lots of models, that the largest errors are in the tropics, but specifically here we can see very large errors over the Indian Ocean and over the Indian subcontinent. And what we see at the bottom is the development of the latest science configuration. So this is in its atmosphere-only version, so GAL9, but this is the atmospheric component of what we call GC5, the Global Coupled 5 configuration. Okay, looks like I've lost my presentation. Okay, yeah, so what we can see here is the significant improvement that took place in this series of model configurations developed between 2012 and 2022. Another area where NCMRWF have been extremely active is looking at the impact of atmosphere-ocean coupling at shorter forecast range. So this is something that we do in seasonal and climate modelling for a long period of time, and we've been doing work over the last 10 years or so on the impact of this on shorter forecast range. So this is a slide that came from Ankur Gupta that he presented in the partnership workshop in 2023, showing the wide range of activities that have been done on these global coupled models, and now the development of regional coupled configurations of the model as well. And these are particularly important over a region like India, where interaction with the Indian Ocean plays such an important role for forecasting over India itself. Another area of expertise in the partnership is for India has been the study of air quality modelling, and anybody that has been outside in the last few days has seen the impact that air quality can have in Indian urban areas. And what NCMRWF have been able to do here is to bring the ability to the model to run at very high resolution over urban regions, and the ability of the model generally in other applications to do predictions of aerosol and chemistry, and to use that for air quality predictions, and to bring these things together to produce a very high resolution forecast for air quality over Indian cities. And this really kind of does set them apart from some of the capabilities that our other partners and other people have across the globe. And finally, the kind of final highlight I'm going to draw on here is something that we've spoken about already this morning, the IMDA regional reanalysis. And so this is pulling together a kind of state-of-the-art modelling system, state-of-the-art data assimilation, and taking this, running it over previous periods with historical observations, producing what's clearly the highest resolution and best quality reanalysis over this region, which, as we've already spoken about, has been cited a large number of times in the literature, and it's been used for lots and lots of applications. And what NCMRWF would be able to bring with this was not only helping to build this system and run this system, but bring in those additional observations that are only available over India. So the assimilation of rainfall observations in this 12-kilometre reanalysis has been a real highlight. So that's just some of the activities that NCMRWF have contributed to in the development of the unified model. But the model itself has served us really well, but it's also getting on. As I said, the first operational implementation was in the 1990s, and whilst maybe it's a bit like is it the ship of Thebes, the ship of Theseus, the kind of, you replace all of the components of the thing, but it's still the same thing. There's probably not many parts of the code that are left over from 1990, but the general structure, including the structure of the grid and the way that the model is held together, is showing its age. So for the past 10 years, we've been developing the next generation model. The model itself is called ELFRIC, which is named after Lewis Fry Richardson, the kind of founding father of NWP. And the whole modelling framework that will include this and the other components like the JEDI data assimilation that Mike spoke about before is called Momentum. And the idea of Momentum is it gives us a model that's fit for future supercomputers. We can run it on multiple architectures. We can run it at very high resolution in global systems in a scalable way on a very large number of processors if we need to. And as well as developing our model and evolving this into Momentum, we've done the same with our partnership. So we've now signed the Momentum Partnership Agreement, and NCMRWF are a core member of the Momentum Partnership and playing a really important role for taking this forward. The focus of Momentum and the priority areas of the partnership are in these three circles. So this is the development of global, regional and local prediction and projection systems, the technical infrastructure that's required to run and develop these applications, as well as to assess them, and as we've spoken about a minute ago, the application of artificial intelligence and machine learning. So not only considering building AI and ML-based techniques into the physical model itself, but considering the role of the physical model for informing operational prediction systems or research prediction systems using AI and ML. The other thing that we've been evolving in the partnership is the structure and how we manage our science. So I think the Unified Model Partnership was very much a kind of spoken hub model with the Met Office in the middle and our individual partners contributing to different activities. But what we found over time was that there are areas where the partners wanted to contribute and work together more clearly, so we try and do that as a whole. But actually, what we're really trying to evolve towards is a situation where different activities have leadership in different areas. So we've been considering what areas with NCMRWF that they would want to lead in, and we had some really fruitful discussions about this yesterday. And so these were some of the kind of candidate things that we've been thinking about, and we really think that the real strength at NCMRWF, where it can really kind of drive the partnership forwards, is in this region of very high resolution model of air quality and composition and chemistry. Another opportunity for collaboration beyond the Momentum Partnership and moving beyond our expertise, our collective expertise of the Met Office and NCMRWF in developing models and modelling systems is WCSSP, which is the Weather and Climate Science for Services partnership. So this WCSSP India project is a collaborative project that allows us to work with organisations across the Ministry of Earth Sciences, not just NCMRWF. We've also brought in academics from UK universities, and we're having some exciting conversations this week about involving Indian universities in this work more as well. And this is a really good opportunity for us to work together to build on that knowledge around our modelling systems, to think about how we take the outputs of these modelling systems and develop them not only so that they're able to produce the products and services that we need, but think about how to produce and deliver those services to the users. This is a kind of summary of some of the outputs of the program in the last few years. So there's a large number of publications, and you can see that while some of these will be led, authored, or authored from one of the countries or the other, that almost half of these have joint authorship between the UK and India. We have regular annual workshops, and we're having a smaller kind of discussion this week about the status of the project. There are various working groups working within this that's bringing people together, and I think this is a real theme across all of this, is bringing people together with different expertise to contribute to this development of our capabilities. And specifically in terms of the outputs of the project, we have new capabilities and tools that have been delivered over the last few years. So that's a summary. It's a really brief summary of some of the work that we've been doing together. And in closing, I'd just like to say congratulations again for 30 years of operational NWP. Congratulations to 150 years of the IMD, and we're all looking forward to many more years of collaboration. Thank you very much.
So if you have any questions? Sir, Dr. Rajkumar.
David, so the Momentum Partnership, the model which you are developing, will target the exascale computing now?
Yes, that's right. So the original program that the Momentum Partnership was developed under was called the Exascale program, and we realised that it was maybe a bit too constrained, and that at that point all we were thinking about was the future compute that we needed to run on. But yeah, essentially the idea is that this is a model that will set us up for another 20 or 30 years for doing physical modelling. That's right.
In your air quality modeling, I mean, what are your assumptions of the sources of the aerosols, particularly in Delhi, for example? You know, you have either farm sources or could be illegal, sort of factories and so on.
So I think you've got the right people somewhere in the room to answer this question. This is a question for NCMRWF really, rather than me. I think there's a combination of climatological and real-time data going in there. So I'm pretty sure that we were talking about this yesterday. Actually, there some of the satellite fire products, for instance, are going in. So the satellite-based observations of where the fires are in real time. So they'll have a slight delay in them, but they are going in. But I don't know if there's anybody in the room who's better placed to answer that question. Do you want to pass the microphone down to Saji?
We have surface emission inventories going into that, and the fire emissions from GFAS real time, near real time, it is going into the Delhi DMCAM model. And the initial condition is after a spin up of 10 days. Every year we initialize that so that it will be stable by 10 days. So initial condition also we are having this, but we don't have the lateral boundary condition from global model, which the UKCA that is aerosol. So, but that is what we are lacking is the assimilation of aerosol. That's otherwise.
So I think we don't have any questions. Thank you, Dr. David. We next move on to the next presentation. The next presentation is by Dr. Mrutyunjay Mahapatra, Director General of Meteorology, India Meteorological Department, Ministry of Earth Sciences, India. As Director General IMD, he is overall responsible for enhancement of observational networks, modeling, forecasting, warning, dissemination, infrastructure for growth of meteorology, weather and climate services of India. Known as the Cyclone Man of India, known as the Cyclone Man of India, he has been instrumental in improvement of cyclone track forecast, lead time period cyclone genesis, extended range forecast of cyclogenesis and other severe weather warning systems of IMD. He brought about significant changes in modernization of weather forecasting, warning systems and services, some of which are so thank you, sir. Meanwhile, it's just
fine. Thank you, madam. Yeah, good afternoon to all of you. Once again, I welcome all of you for this technical session. And I feel privileged to be a part of this celebration and this technical session. I also feel somewhat when I have listened to three giants prior to me, and people like Dr. Farrier and Dr. David and Dr. Prasad have spoken about NWP. So I feel I am just a user of NWP, so I will be speaking about the usefulness of the NWP products, more or less, and how it has changed over the years. So it will be following to some extent what I told during my speech in the inaugural function. So, yeah, fine. This is not working?
It's working, but directly, that's why.
But click here. Okay. So the story actually I just told you in the, okay, I'll just take out to that 1785 is the first observations in the country. And then we came up with the port warning system in 1865. And after that we marched on with the establishment of 1875. And it was the first organization in the country to have a message switching system for global data exchange. So one of the first few electronic computers when it was introduced in the country that was provided to IMD for scientific applications in meteorology. And when you think of the satellite, the first satellite when it was launched in the world, IMD was utilizing that in 1960 onwards. December 1963 we got the receiver, but also we got all the pictures prior to that. Similarly, when INSAT, International Satellite, was launched, there also IMD was the first and foremost user of that. And also IMD was a player to formulate the policy and plans for the satellite system in the country. The evolution of the science and technology and the services over the years have been marked by the many milestones. I will just restrict myself towards the role of NWP and two subjects. One is the monsoon and the cyclone. Of course, there has been overall development. We are first confronting with the large-scale synaptic systems like monsoon, planetary systems, then synaptic scale systems like cyclones. And afterwards, of course, now we have come up with the capability when we deal with even very small-scale or mesoscale weather events like the heavy rainfall, localized heavy rainfall, or the thunderstorms, lightning, squalls, hailstorms, etc. So what happens actually? In more than 300 years ago, Halley in 1753 proposed the main cause of the monsoon was the differential heating between the ocean and land. And it was considered to be a giant land and sea bridge. So that understanding itself led to the prediction that if we can have very good information about the land bridge and sea bridge, we can perhaps predict the monsoon. Then people could think that there is the variation from month to month and season to season and year to year. And Blandford in 1887, it appeared that average rainfall of the whole country was 42 inches. Now, if we just look at it, it was based on 1,500 stations undivided India, which included then Burma and now Myanmar. And now also, if you just look at the annual rainfall of the country, it comes out towards that. That also gives us an assurance. There is an assured rainfall activity from the monsoon, which is the bread and butter of the country. And it has not changed over the years. Even if there is large-scale impact of the climate change, but the total amount of rainfall which is occurring in India is not changing. That is a very good assurance by the monsoon god that Indian economy can have stability if you can really utilize the amount of rainfall being received during the monsoon season. Then, of course, as I was telling a little earlier that there were various interventions, and Henry Blandford came up with the first monsoon forecasting system. And Cherrapunji actually at that time also range of rainfall 500 to 600 inches in Cherrapunji to 1 to 5 inches in Sindh. It was stated at that time. And now also you know that Cherrapunji now it is Mausun Ram, which is the rainiest place in the world. So John Elliott published meteorological memoirs and rainfall map for the first time in 1906. Then we came up with the Simon-Strand gauge, which was adopted as the standard for all states, and IMD was authorized as the rainfall registration authority. So that is the beginning of the rainfall monitoring in the country. And after that, of course, there has been many evolutions in the rainfall monitoring systems and rainfall analysis. And to mention a few, it is Sika 2003, then we go to Wako in 1910, Partisan Mule in 1978. And then 1992, we started with district rainfall maintenance scheme. Somebody says that it started in 1986. But at that time, we could not archive the data, but archived data are available from 1992. But we have planned and we are going back to prepare the DRMS, the district-wise rainfall monitoring system. But operationally, district-wise rainfall information was provided to the government and the people from 1986, and it was archived in 1992. Then we came up with the graded rainfall data. That was the requirement of the modelers and various types of users and planners. So 0.25 degree into 0.25 degree graded data came up in 2007 with Rajivan. And that has gone also many other informations. And recently, one paper is coming up with 0.1 in 0.1 data with IIT Delhi and NCMRWF, IITM, and IMD combinations. So that we are moving towards this year itself to 0.1 degree and 0.1 degree rainfall data set. In the meantime, as you have seen from the presentation of Dr. Prasad, we come with IMDA, which is providing a variable source of data for NWP observations, modeling, etc. Now, this is the first long-range forecast as we are talking about. It was issued on 4th January 1886 by Henry Blanford, based on the amount of Himalayan snowfall in winter. It was a qualitative statement, but however, the beginning came because of all of us know that 1866, 1867 was unprecedented, 2 consecutive drought years, and people, you can see the status of the people at the time, and famine occurred in the country again in 1877, 1878 monsoon. You can find it in the British Library. So all these prompted to have the long-range forecast of monsoon. It was based on the relationship between Himalayan snow cover in the month of December, January, February, followed by the monsoon in the next year. Now, if you go towards that, then the next phenomenon came with it, Walker circulations and Walker and 1932, you can find out this one phenomenon is described. Gilbert Walker named these fluctuations as southern oscillations. So he established southern oscillation involves for more than a seesaw in the surface pressure across the Pacific Ocean. And afterwards, all of us know that how the evolution is taking place, and now we have got to end so. So there has been a correlation with Indian monsoon with various types of fluctuations. You can find out very old studies are there. I was talking about ENSO, then North Atlantic oscillations and many other, etc. And finally, we could find that it is not, that is the beginning to say that monsoon is a global phenomena. It depends on various global parameters. And if you really want to predict monsoon, you have to go for global circulation features and global modeling. So then gradually we started with that statistical modeling from 1905 onwards, you can say, and we went on various phases, sometimes all India, sometimes Northwest India, sometimes Central India from Northwest India. So like that, various evolutions took place with the statistical modeling. And another breakthrough came in 1988 when we went for parametric power regression models based on 16 parameters. You can see the 16 parameters. So many of these parameters are related with the temperature, snow cover, all these parameters, but it is distributed globally. But these parameters are not independent of each other. And then people thought that, yes, we should think about that, why to utilize so many parameters. Then we came up with statistical ensemble forecasting system in 2007, where 8 parameter model was considered. From 16 to 18 we came off, and different period of time, these parameters, different parts of the globe are taken up, and we went for the further improvement in our statistical ensemble forecasting system. This is the first time the ensemble forecasting came from the statistical methods. So then the era of dynamics came, that is dynamic numerical forecasting system for monthly and seasonal forecasting, 2005 to 2012. So we came up with the atmospheric global circulation model climatology, 1985 to 2004. Thanks to all our modeling communities in the country, it is IITM led effort which led to the experimental development of the dynamical model for forecasting of monsoon. Then we came up with the monsoon mission. Actually, 2012 monsoon mission commenced, and now we are coming in the monsoon mission phase 1, 12 to 17. And then we came up with phase 2, then now in phase 3. While moving from monsoon mission phase 1 to phase 2 to phase 3, the first one targeted development of the modeling system. And then we came up with the modeling system in the phase 1 for experimental interpretation of the global dynamic model for monsoon forecast in seasonal range in 2012. Then by 2017, we have got the operational dynamical modeling system, that is MMCFS, Monsoon Mission Climate Forecast System, to predict monsoon for the 4 months, June to September. Then, of course, we came up with various development, that is post-processing products, not only seasonal scale, but also we went to the extended range forecast system. We came with the extended range forecast system again in 2012. Experimentally, IMD started based on the NCEP model, based on NCOM model, based on other global models. And afterwards, in the MOES family, we took off and we developed with IITM, that is extended range forecast model. Now, afterwards, we came up with the NCMRWF extended forecast model. Now we've got two extended forecast model from IITM and NCMRWF, and it is run operationally. NCMRWF model is run operationally in NCMRWF, and IITM model is being run operationally in IMD. And then also we take care of other extended range forecast models available in the country. Then we came up with that. Simultaneously, also during this monsoon mission, we targeted the short range forecast models, short to medium range forecast models, and we came up with the various versions. I will not discuss here. Already it has been discussed by Dr. Prasad. So what I want to say that after all these developments now, in 2021, we took another major breakthrough. So that is that we did not depend upon one dynamical model. We went for multimodal ensemble forecasting system, where almost 10 global ensemble forecasting systems and deterministic models were taken off for the seasonal forecasting system. And out of that, we every year, it is not static, it is dynamic. Every year, at the month of April, we decide best 5 models based on their hindcast, performance, etc., the continuous evolution process and statistical robust mechanism. We go for that. Then that 5 models are given the weightage based on their performance, and we go for MME. And with that MME, we started giving forecast. Till then, it was the forecast only one figure. Say, for example, 106% of the long period average for the monsoon seasonal rainfall during June to September. But that is not the case in 2021. In 2021, we told, yes, total country as a whole, what will be the rainfall amount, but what is the distribution of rainfall in different parts of the country? It is spatial map was generated in 3 categories, that is above normal, normal, and below normal probability of rainfall during the monsoon season. We did not stop there. We went for monthly forecast. This is the first time IMD issued the monthly forecast based on the multimodal ensemble. Similar pattern, and that continued, and now every day, not only for monsoon season, every day, every month we issue the forecast for the next month and next seasons. So this was the breakthrough we came up, and this is a probabilistic forecast. So then this is just one example for 2024 southwest monsoon season. This was the forecast issued in the month of April. You can just think about that. What is the realized rainfall distribution this year, and what is the forecast? If you just remember, it was a very good rainfall this year. It was 107.6, and prediction was 106% plus minus 4%. And it was predicted that except Ladakh, Jammu and Kashmir, parts of Northeast India, parts of Odisha, and adjoining Ganges, West Bengal, Jharkhand, the remaining parts of the country will have normal to above normal rainfall activity. That was the forecast. And now we find what has happened actually. So if you ask me what is the forecast accuracy, I will say it is about more than 90% the spatial accuracy, and also the magnitude has come up very well. So this is the development which is taking place. It is not because of simply the multimodal ensemble forecast system what IMD has developed. It is because of the improvement of the individual models. So individual models have developed well over the years. Now the seasonal forecast system, and out of that the best one we are considering, and based on statistical dynamical modeling, we are going for this type of forecast system. It is not only for rainfall, now we are providing for the temperature, both the maximum temperature, minimum temperature, and we have gone one step further also. We are calculating the extremes. We are providing the probability of heat waves, probability of cold waves, and probability of the hot spells and cold spells based on this seasonal forecasting system, followed by the monthly forecasting system. Now, I will just speak a little about the extended range forecast system. Yes, as I was telling you, experimentally we started in IMD in 2012, but operationally in MOES we started in 2017. So it was the extended forecast system based on the combination of the NWP and the CFS and GFS, and then finally it went on improving gradually with the improvement in individual models. Now, these are the very good system what we have come out, which has filled the gap between the short to medium range forecast and the seasonal forecast. Now we have the seamless forecast system because of this one, and we could predict very well the occurrence of wet spells and dry spells, or occurrence of the hot weather and cold weathers, and therefore it has helped the improvement of the forecast systems. So these are some of the examples, just one example I put up here in August 2024, how the seasonal forecast followed by the extended forecast could help to indicate the wet spells and dry spells. Now coming to the basic NWP, which usually we feel that it is meant for short to medium range, I'll just say that a beginning was made in IMD, just like you told in 1952, We made it in 1958, the first classical paper by Dr. P.K. Das and his collaborator. The early days were very challenging actually. As I was telling you, we did not have the computer. We have to move to other station in Mumbai. Our people at Pune, they are going to Mumbai. And people in Delhi, they are going to planning commissions to punch the data. And accordingly, I think here all our stalwarts are there. They will remember those golden days, though it is hardship, but they enjoyed it that time. And they have come up with that. Actually, we are reaping the fruits now. Whatever the hard work has gone at that time, it has improved over the years by the generations present here, and we are enjoying with that. And we have now a prestige to say that we belong to the meteorological community. At that time, we are not willing to say that we are from meteorological community because our forecast was not so good. But now everybody in India can tell with his head high that we belong to meteorological community. Forecast has gone right. So congratulations to all of you. So now what I want to say that initial speed of growth of NWP was a little slower, but after the establishment of Minister of Earth Sciences, there has been a paradigm shift. As Secretary Saab was telling during his speech, there has been complete integration, not only for the institutes, but also the human beings. Now, gone are those days when NCMRWF scientists will not talk to IMD scientists, IMD scientists will not talk to NCMRWF scientists. Now, whole belong to all family. They talk to each other, they work with each other, they publish with each other, and therefore the science improves, and technology improves, and forecast is improved over the years. Now, this is the Dr. P.K. Das paper. I've just put off here. It is published in Monsoon. Mausam. So, Mausam is the journal published by India Meteorology Department. It is the only scientific journal dedicated to meteorology completely, which was published in 1950. Just imagine. And we are going to celebrate 75 years of Mausam, and is planned for 12th and 13th January of 2025. So, this is the contribution of the R&D community. This is academia, R&D, and all students. Everybody has responded, and we have grown in the field of science. Now, if we just look at decadal evolution of NWP from 1950 to 1990, it was the decade of 60s. The first paper on NWP, as I told you, Dr. P.K. Das came up. In 61 to 68, actually, IMD had no computer. We went, as I was telling you, Delhi University, New Delhi, to use the computer system also. At that time, IBM 1620, ICL 1901. From 1969 to 1980, so formation of NWP group in IMD. So, I think you can remember that in 1969, IMD New Delhi has the NWP group. They acquired with mainframe third generation computer system, IBM 36044 with 512 KB memory. So that is the beginning. It was installed in 1973. And then the commencement operation NWP started gradually, but people are not willing to utilize the IMD products. There has been hindrance, there has been opposition, there has been conflict, but finally we accepted. So now you just imagine the society, the meteorological community has moved from an unwillingness to the willingness now and demanding now, and based on demands, now value chain is established by the modeling group across the world. Now, there are many visionaries who contributed to the growth of NWP in India during difficult periods of early days. Now, the establishment of NCMRWF in 1988, I think that Prasad has told already. I will not talk much, but story goes behind that. As you can find out, the Institute of Tropical Meteorology was established in 1962. And it was planned at that time that it will look special tropical meteorology. When you speak of tropical meteorology, it's the monsoon, which is very important. But more or less, work was confined to the statistical in nature. It was not in dynamic in nature. And finally, the NWP research activity gained momentum during early mid-1970s. And told actually, and 1977 actually, the drought of 1982 severely affected Kharif and Rabi crops. And then the idea came that we should have the system and the institutional mechanism. Therefore, in 1988, we came up with National Center for Meteorological Forecasting, located in Mausam Bhavan, IMD New Delhi, and many scientists from IMD contributed and moved to. And of course, Professor Mohanty and some people also moved from IIT Delhi towards NCMRWF. So during that time, we acquired the supercomputer, but if I remember, and people have told us that the story goes to 1982, when people talk about then from Prime Minister Indira Gandhi time, that Dr. P.K. Das even also talked to Honorable Prime Minister at that time, highlighting the need for the computing systems. And those days, but finally, actually again, then Prime Minister also talked to Dr. Reagan, and we got the supercomputing system. The first operational forecast began in 1994, for which we are gathered here to celebrate. Now, if you look at 1990 2010, it came up with the Cyber 2000U, and that was Dr. T.N. Krishnamurthy helped us, and we should express our gratitude to him. Then we came up with the quasi-Lagrangian model. That's the first model that I was telling that it was operational. For cyclone forecasting purpose, we utilized quasi-Lagrangian model at that time. It was providing forecast for 48 hours, but forecast was not good. But still then, something went on. Before that, we came with the Kuiper systems. Then 1 to 8, with phase out of the Cyber 2000U computer system in 2000s, IMD acquired the SJ Origin 200 and Altix 350 servers. And then 9 to 10, the HCL Infosys system came up, and then it was a big jump, I will tell you, 2009 to 10, and when we have the running of global models and mesoscale models with triple nesting started. So therefore, there is a quantum jump in 2009-10 with respect to NWP modeling. And I will tell you at the time Tagisa was there, he decided that let us have NWP modeling not only confined only to Delhi, but also there should be 9 centers. So he established mesoscale modeling system in 9 centers across the country. But however, we could not sustain that, and the policy planning also changed, and mesoscale modeling got confined only to Delhi and not to our regional centers. So this is the migration of computing systems over the years that I have told you already. So this is the HPCS in IMD, HQ and various centers in 2010. That's I have told you. We came up with the implementation of mesoscale modeling system, at that time MM5. So operation NWP 2010, if you just look at these are the systems. At that time, the international collaboration was key to success. It was going on. Another international collaboration came up at that time, that is the TIGI. That is Grand Global Ensemble Systems, Tropical Cyclone Track Forecast. We came up with the ensemble forecast system, the tropical cyclones track, with the help of TIGI. In 2012, it was implemented in IMD. Then, of course, we ventured towards other regions like polar WRF, etc. Then hourly specific information was generated with WRF 3 kilometer. Then ARS model was taken up for radar data assimilations, the first time radar assimilation taken up with ARS data. Then NAMCA system also came into existence with the Commonwealth Games. Then short range forecast, if you just look at, actually at that time we got the 27 kilometer resolutions, then 51 ETA models like that, then area with the RSMC domain, and triple nested we started, then 27, 9 and 3 kilometers, and all these development took place with Commonwealth Game 2010. So this is some of the products. I will just leave it what went on. Then MOS Aditya and Bhaskar came off in 2014, and then we came up with Pratyush and Mihir in 2018, and another major breakthrough. So there are different phases when you come up with development of the NWP modeling systems. So this benefited everyone, and then there was systematic distribution of work. So now the NCMRWF became the modeling center, a real modeling center with the data assimilations. Then it was decided that IMD will confine only to the regional modeling. And then IIT was given the process studies. We should go for the science of the modeling systems, parameterizations, etc. Then we came up with all these developments. I'll not go through all these things because Dr. Prasadji has already discussed that. But what I want to say that upgraded modeling system came off time to time. And recently, what happened in the last 2 to 3 years, that is the integration of the nowcasting. So far, we are doing modeling with respect to short range, medium range, extended range, seasonal range. There was no model with respect to nowcasting. We came up with 2 nowcast models. One is the HRRR with the help of ISRO. First time it was introduced in 2021, 2 kilometer resolutions. Now we are going to 120 resolutions, where radar data assimilation is ensured to prepare the forecast for next 24 hours. Then we came up with 2022, the EWRF, that is electron WRF, with the assimilation of the lightning data. So all this development took place with the help of other agencies also. We have got the Indian Air Force, we provided the lightning data. Now also it is being provided. It provided the detection of lightning. It all happened with a disaster again in 2018, when around 82 people died in Agra and Delhi in this area. Then there was hue and cry and PMO. Then we went for the first time lightning warning system developed jointly by the NCMRWF, IITM and IMD. It became applicable from April 2019. So then this is the 5-day MME. So that's what IMD has done. That is the multimodal ensemble forecast system. Now if you go to any forecast which IMD is issuing, whether it is seasonal forecast or extended forecast or medium range forecast, short range forecast or nowcast, it is the multimodal ensemble. So this is just an example of multimodal ensemble for the heavy rainfall forecast, what we do in IMD. So this is just the story what we have come from. I'll just add some of the story here. Want to say that modeling cannot survive on its own. Modeling is a part and parcel of the entire game. And when you play a game and weather forecasting the initial problem, the observations, as Secretary was telling, the first and last pillar plays a dominant role also. The first one lies with IMD, that is observational systems. So observational systems also enhanced over the years in different phases, and important phase was the modernization phase 1, taken off in 2007. And then we came up with continuous upgradation enhancement with across schemes, and now the Prithvi scheme, and now the Mission Mausam. I thank Dr. Vijayendra Saab. With his leadership, we could get the Mission Mausam. It is a very ambitious project. It is a very time-bound project. It is a challenge to each of us to implement the Mission Mausam during the next 2 years. Of course, if we can implement it, then we can go for further enhancement of the Mission Mausam as told by the government. So what I want to say that there is a mechanism. In the parallelly, there is a mechanism for continuity, continuous flow of observations, decision support system, to utilize the information, to have a comprehension, comparison, analysis of observations and modeling, to find out which is the good model, which is the best model, which is the better model, which is the poor model. Now I will tell you, we have come up over the days where we were hesitant to accept the model. Now we are in a position where I can utilize a wrong model. If give me the output of a wrong model, I can make it right in my interpretation. I means IMD can make it its own interpretation. So that knowledge has been developed over the years, how to interpret, how to utilize, how to modify, how to post-process, so that final forecast can be better than the model forecast. Now this is observational systems. You can say that you can imagine how much observational system has improved over the years and how much data is being assimilated that Prasad has told you. It is impossible because of the dedicated observational systems, quality-based observations, more dense observations, more frequent observations. The automated systems have come up, many systems have come up. And right-hand side is the decision support system where we compare, compare, and analyze different types of observations. You will be happy to know that at present we are not dependent on anyone. It is completely made in India, in the sense that the entire forecasting system, we are not having decision support system developed by Meteo France now. It is our decision support system. Okay, so like that, the various products which are being generated, it is completely sustainable and completely collaborative way development within the Ministry of Earth Sciences, supported by, of course, academic R&D within the nation and outside. So this is the radar network. You can see over the years, we started with 11 cyclonic detection radar in 1973-74. Prior to that, of course, 1950 we started the first radar. Indigenous radar came up in 1958 in Safdarjung itself. And now we have got 40 deployed radars. And right-hand side, you can see the plan for 53 radars under the Mission Mausam. So like this, the global data decision system, now we are a WIS recognized center. It is a Global Information System Center. And the second version of WIS is implemented, where not only the data which are being accessed earlier in the global telecommunication system, but now you can see the data, you can visualize the data in open platform. Any individual outside can visualize the data in open platform. So this is the concept which has come up with public-private partnership in WMO, and we are also a partner towards that. Now I'll say one example. Till today, where there has been a lot of development. As I was telling you, we started with TLM. And this is the model forecast based on the various models you just imagine. I just put up here about 9 model forecast. And in between, the multi-model ensemble is in the blue one. It is written MME. So you just imagine. So even though there is development, there are still scope for improvement of the models, but the forecasters are also now intelligent to utilize the model information and provide the forecast accurately. And right-hand side, the operational forecast. You can see the operational forecast is mainly based on MME, but it's not exactly MME. Again, MME is initialized with the initial condition based on the observations, and required corrections are made in MME output, and then it is optimized, net smoothing, and final consistency check is carried out, and final forecast is provided, as you see on the right-hand side. So not only that, but for assessment of the models and assessment of the winds also, there are a lot of information available nowadays internationally. You see, we have got the climatology, which was not there earlier. We have got the observations from various types of satellites. We have got the actual observations from high wind speed recorders and automated weather stations, and buoys, ships. So there has been overall development within the Ministry of Earth Sciences and outside also to improve and augment the initial status which is required for Prasadji to run the numerical regression models and create the first guess. Then after that, of course, there has been studies by the IITM and others, academics, R&D, etc., to understand the parameterization and physical processes. Now, if you just think about that, Gone are those days we are not accepting, but now you go to any institute, you will find that people, either professor or the students are running WRF or some other model, and they're going for, they are nothing that they're going for climate change model, they are based on the data from IITM. So this is the condition now. It has spread, starting from Andhra University, now it has spread to all academic R&D, people are involved in these modeling systems. But we have gone one further step. What is that actually? Now we are not providing simple forecast, we are providing impact-based forecast. Now we have moved from simple numerical modeling, numerical representation modeling, to the impact modeling, hazard modeling, impact modeling, and the risk assessment. So this is what we're doing. We have got different types of features. From there, we got rainfall informations, the wind information, the surge information. This is just an example of rainfall information. Just imagine how we are getting from different features from different sources, and finally we are giving the forecast for rainfall. And this is the storm surge. This is another collaboration story, how the INCOIS, IMD are working together, and we are providing the storm surge and coastal inundations for each and every village across the coastal lines. And of course, at the same time, we have calculated the based on past data, we have got the probable maximum storm surge. The story goes on. The story starts with the GHOS 1977 from India Meteorology Department. He develops the nomogram. Now also based on nomogram, you can give the forecast. This gives the storm surge height. Then the development takes place, the Dallas-Nesky theory, which was utilized by GHOS, was adopted by Dr. S.K. Dubey to develop the modeling system. And then the story went, and we came up with the coastal inundation systems, now Professor Reddy Rao and here the INCOIS. Then finally, we came up with the probable maximum storm surge. What is the requirement for the planning purpose? We provided this information based on the modeling study, based on observation study, and that is being utilized not only for purpose of forecasting, but also for planning purpose. So this is the real-time impact forecast systems. You can see how the hazard modeling has gone up over the years. I'm just taking one example for cyclones. Similar examples are there for heavy rainfall, heat wave, thunderstorms, etc. So this is where this is another example of collaborations, how the various institutes, starting with the NRSC, the various space agencies, INCOIS, IMD, then flood meteorological offices, then many others are working together to prepare the forecast for surge height, coastal inundations, wind speeds, inundation extents, depth, etc. Then combination of everything. Then we combine with the socioeconomic indicators like population risk, impact on buildings, impact on essential facilities, impact on transportations, etc. So this is the way forward, where we have come up a long way with the help of the integral development. So this is just an example of the impact-based forecasting. So it is beyond numerical representation modeling. Now the challenge for the NWP modelers are, you cannot give simply NWP forecast, you have to go for hazard forecast. And for this purpose, you have to prepare for that. You started this journey in Ministry of Earth Sciences, but you have to go a long way to give a realistic hazard forecast which can be utilized for impact-based forecast. So this is an example of impact-based forecast for flood, wind, and surge. It is not simply the impact-based forecast for the hazards and the impact and risk, but also now we have gone one step further, that is the risk financing. 5 days ahead, when IMD says that cyclone is coming and it will hit Odisha coast near Dhamra port, this information goes to National Disaster Management Authority, Prime Minister's Office, each concerned state authorities. Then, with this web-based dynamic composite risk atlas systems, they can find out which village is under the threat of flooding, which village under the threat of wind, which village under surge, and how much will damage in terms of the operating of telephone poles, operating of electric poles, how much will damage to the standing agricultural products, how much will damage to the houses, how many houses will be damaged. And these are quantified. All these quantified structural damages and non-structural damages are converted into rupees. At that table I have shown here, this is the expected losses. So this is the loss forecast. So we have gone to the loss forecast due to tropical cyclones. Now we have to go like this for each and every hazard. So that is the forecast required in future. And for this purpose, it is not simply the numerical modeling group, but also other modeling groups, socioeconomic modeling group also have to work together. And that is the future where the Ministry of Earth Science, IMD, IITM, NCMRWF, INCOIS, and many others have to move together. So this is another point, that air quality modeling, it is a serious issue. All of us know that some people were showing apprehension whether NCMRWF will have so many people from outside, whether people come here in spite of this air quality deteriorating in Delhi. Yes, of course, this is the case everywhere. It is not Delhi alone, but Delhi has its own peculiarity. The climate supports the sinking motion during this time, and hence the acquisition of the pollutants, and therefore it goes down. during this month of November, December, January, February. But we have come up a long way. Here again, the international collaboration, we have gone with the Finland and many other countries, and we have got air quality early warning system in IITM and IMD and NCMRWF. All together, we are providing every day. It goes to Center for Air Quality Management, the forecast. Even our forecast is being referred in Supreme Court. Of course, there are a long way we have to go because it is not simply the weather. Here, the role of man-made activities plays dominantly, and which cannot be predicted. It is very difficult to predict. So therefore, we have to think about the ways and means how we can improve it further. So this is the status at present, starting from very few hours forecast to seasonal forecast and forecast for each and every parameters. But when you go for the future plans, as I have discussed some points during my talk, we have to go for the improvement of value chain continuously, continuous upgradation of the value chain. And that value chain starts with observations, then modeling, forecasting, severe weather modeling, sectoral applications, including the R&D. Then, of course, we have the dual engine or dual the twins, what you say, and that is required, and we have adopted that. AML has already started. There is a group working in AML in Ministry of Earth Sciences. There is a dedicated group in IMD itself, and already some development is there. I will tell you some of the small developments in AML are being utilized operationally by IMD also at present. For example, nowcasting for satellite T intensity number determination by AI, like that we have gone for some development based on radar data also. Now, dynamic impact-based forecast risk-based planning for all types of severe weather, as I have given you the example, it has to be developed for all. The last mile connectivity, of course, all these are being addressed through the various projects being taken up by Minister of Earth Sciences under the leadership of Dr. Rajivan. So this is one of the important mission MOSUM, importance of the project I just tell you. The implementation of mission MOSUM will contribute towards strengthening of observation. That is the most and first and foremost requirement, and that is addressed in mission MOSUM. In situ and remote sensing both will be addressed there, and gaining better understanding, science, innovation and methodology, that will be taken care, and improve our model assimilation and augmentation of HPC, that is also being taken care, and forecast dissemination, that will also taken care through effective communication to the society. And we are in alignment with the WMO for and UN bodies for early warning for all. We are not helping to ourselves, we are also helping other countries in South Asia, Middle East. There are 30 countries identified by WMO to improve the early warning, where there is no early warning at present, and we have committed to be partner in 5 countries. We will be the peer advisor to provide support for implementation of early warning for all in 5 countries. 4 countries are in South Asia, 1 country is Mauritius. So with this, I will stop here, and thank you very much. Yes, sir.
Like to, because from 90 onward, forecasts were issued by NCMRWF. I think I am loud enough.
Sir.
Forecasts were issued by NCMRWF.
It will not go to the system if you do not speak there.
Okay, forecasts were issued by NCMRWF for first 7 agricultural units, then 20 agricultural units. I had K. V. Raghavan, who was a forecaster, and M. G. Gupta hired for contract basis. That's one.
Yes.
I went for ECMWF conference in 1982. I was invited. I went there. I saw the supercomputer first time in my life, and I saw the medium range weather forecasting, beautifully done, but nothing proper of monsoon. So I projected these are the wrong thing there. So I was invited to become a senior scientist on there, which I was not allowed to go by the IMD. Okay, that's a separate story. But afterwards I went, I wrote 3 reports. But afterwards I started working on medium range weather forecasting as a group of SAARC countries. But when I prepared the plan, Bangladesh came forward that they want to have the SAARC center. So I then forgot that medium, because we are trying to get ETA 10. So I then started working for IMD. 85 I projected it and got it approved by the ministry. But by beginning of 86 we were transferred to Department of Science and Technology. Professor Jaspal came as a secretary. So I projected to him. He agreed, but then he went as the chairman UGC, Dr. Gwarikar came. Then 3 of us, myself, Dr. Mishra and Dr. O.P. Sharma of IIT were sent for benchmarking all the computers in USA and Japan. Then the committee report was prepared. Number 1 was CRE-XMP, number 2 was ETA 10, number 3 was S1000. Now, This went to Department of Electronics, and then DRDO, Department of Electronics, and DST. They were three community working together, and people were talking on number 2 and 3, number 2 and 3. So then I realized after 2 days why they are worried. I said, okay, if you don't have any problem in number 1, let us select the Cray XMP. If we are not able to get it, then we have the next benchmarking. So that's how the Cray XMP was approved. That's all I had to tell
Thank you, sir, for sharing.
But you had talked beautiful. I am very impressed with IMD because I put in 27 years in IMD, but it's a wonderful thing. Thank you.
Thank you. Yeah. Thank you, sir. Thank you, sir.
I join Dr. Datta in complimenting you and the achievements of IMD, and your value chain proposition is very good, but the ultimate link of value chain should be the society.
Yes.
And the sector users are there, see, maybe somebody will benefit, but a common man and those. So you have to have the civil society engaged, and various, professional society like India Med Society and many, they should be a vehicle to do, because no department of itself can interact with such a diverse country. So we need to factor that also in our planning. Thank you.
Thank you, sir. Thank you.
Thank you, sir. We are running late. We just have a small short talk. So for this talk, I invite Mr. Karma Dupchu, Director of National Center for Hydrology and Meteorology, NCHM Bhutan. NCHM Bhutan is an autonomous scientific and technical agency of the Royal Government of Bhutan for science of hydrology, meteorology, cryosphere and its applications. Mr. Karma Dupchu has served in various technical positions in the Department of Hydromet Services under the Ministry of Economic Affairs, Bhutan. He is a serving member of Permanent Representative of Bhutan with WMO. He is the co-chair of Outcome 4, Climate Change and Disaster Risk Reduction for UN Sustainable Development Partnerships Framework, governing body member of BIMSTEC Center for Weather and Climate Center, BCWC. Sir, I request you.
Very good afternoon, Honorable Secretary, Minister of Earth Sciences, Director General, Indian Meteorological Department, Head of the National Center for Medium Range Forecastings, the former DGs, the Head of the NCRMs, and the distinguished guest, and also the dignitaries. In fact, after listening to the lot of technical presentations, I realized that it may not be necessary for me to make the presentations, or whether really the BIMSTEC centers of weather and climate we really need to establish, because I think looking at the histories, I think the government of India has everything, and also there's a lot of international collaborations that data and the products are making free accessible. But however, I think I will, since we have the governing board yesterday, and I was asked by Dr. Prasad to share about thoughts and a way forward for the BIMSTEC Center for Weather and Climate. And first of all, I think I would like to thank the NCMRWF for extending the kind invitations to all the governing board member of a BCWC to extend today's event for celebrating 30 years of the operations of the NWP in India, and after the 150 years of IMD. And I also like to acknowledge and the opportunity given today to share the thoughts on the importance of the BCWC and promote the South-South cooperations between the BIMSTEC states. And I would like to once again thank the NCMRWF. Today's event particularly is not just a celebration of 30 years of the operations of NWP and of the 50 years of IWP, but it is how much the IWP products and contributed to improve our broadcasting capacity and the delivery of early warning services for the safe life and property, and of course to acknowledge and offer the gratitude to the personnel and who made the selfless support and contribution to the operation of NWP and delivery of services and products. And we also like to express our appreciation to the Ministry of Earth Sciences, India, Department of Indian Meteorological Department, NCMRWF, for making the product and the services accessible to the neighboring countries. On the behalf of the BIMSTEC Center for Weather and Climate Governing Board, I also like to congratulate the Ministry of Earth Sciences, Government of India, for acquiring the new high-performing computing systems for the weather and climate research, and which was formally inaugurated by the Prime Ministers of Shri Narendra Modi in September 2024. I am sure that this system would not only benefit in India, but also significantly benefit the work of the BIMSTECs and the neighboring countries, and this would further promote the collaboration and cooperations in the region. And we know that every year around the world, at the region, at the national levels, we are experiencing the extreme events that bring loss and damage to the life and property. In particularly South Asia, we are quite vulnerable to the weather and climate related disasters, with more than 700 million people impacted by one or the more climate related disasters in the past decades. And the climate disasters do not stop at the national border, and the region is living through the new climate normal and other extreme events which challenge the capacity of the government, business, citizens to adapt. And the extreme events also impact the productivity and the performance of businesses and citizens, and particularly, I think, bring a loss and damages to the billions of dollars. The resilience to the weather and climate impact fundamentally rely on the importance of the forecast, short-term forecasts for informing emergency preparedness and evacuations, mid-term forecasts to reduce loss and increase the productivity of the climate-sensitive sectors, and long-term forecasts to improve to the climate-resilient planning. Unfortunately, the many national hydrometeorological services in the regions have a severe limitations in terms of funding, in terms of skill, in terms of human resources, and to respond to the increasing service needs of the users, and struggling with the keeping with the rapid advancement of a science and complex hydrometeorological technology around the world. And considering that, particularly in the South Asia, considering the transboundary nature of the climate and the weather hazards, and diverse level of the capacity and expertise across the country in South Asia, the regional collaborations offer synergies and economic of scales that not only benefit but essential to meet the rising threat of the climate impacts. South Asia share the same geography and influenced by the same impact by the same weather and climate. And therefore, BCWC is the future of NMHS collaborations and partnership in the region, as India has the resources, has a technology, has a leadership in promoting the regional cooperation, and has been supporting the BIMSTEC Center of Weather and Climate as a part of strengthening the National Center for Medium Range and Weather Forecasting. And with the signing of the Memorandum of Associations in 2014, I should share that this BCWC has a political commitment from all the member states. And therefore, the BCWC Center is one of the first, in fact, among the 6 centers to be established and the BIMSTEC centers that has been established and now in the process of formation. And I also see that BCWC has a great potential to provide the regional mechanism to develop capacity for the improved hydromet and early warning services to the resilient disasters risks. To way forward, I think most of the things has been said into the presentations, but important things, I think, as a member of the states, the government of India has, I think they have, in terms of expertise, in terms of compensation facilities they have, but as a member state, it is very important that we enhance our observation network and share the data in terms of automatic weather station observations. Maybe in future, I think we need to expand to the more radiosonic station in the network. Maybe like weather radar in the in the future. But secondly, I think currently the BCWC is kind of in a stage of development. Therefore, it's very important that we enhance the visibility in the regions to enhance collaborations. It is very important that I think we may have to work on the regional projects with the global initiatives to improve the forecasting. And of course, I think by listening to today's presentation, there are so many things happening in India, and BCWC should build under the existing international and the regional collaborations. Particularly, we know that IMD has been the leading center for under the WMO, particularly in the RFO, and therefore we have to recognize this, and of course the Dr. Mohabbat's leadership in the international forum like WMO, serving as the executive council members for the RA2, and of course the third vice president of WMO. And also I think IMD hosts number of internationals like regional climate centers, regional training centers, regional GTS centers and exchange, and of course the leaders in the South Asia flash flood guidance, and also the special severe weather, the tropical cyclones. I think BCWC recognizes, and we have to build any kind of activities along this these internationals and the regional mechanism. And of course, I think it is very important that in South Asia and in the BIMSTEC regions, I think it's very important that BC should also foster the sub-regional research, specifically for the mountain meteorology as well as in the marine meteorology, I think which very well advanced in the regions. And of course, I think for the immediate need, I think the BCWC should focus on the capacity building of NMHS in the region. And lastly, I'm confident that under the BCWC umbrella, we can grow our service delivery capacity in a faster manner in a cooperation with global and regional knowledge under the service partner. The governing board of a BCW has been discussing the future of a BCWC, and the good progress has been made for the last few years. And only our wish is to grow the BCWC as a primary centers with 24/7 operational services, producing and disseminating numerical weather services to the member states. And today, as we are witnessing the celebration of 30 years of NWP operations and 150 years achievement of the IMD, I strongly believe that in the next few years, BCWC will also make the tremendous progress and under the support of the government of India, and we shall maybe come here again and celebrate these achievements. Lastly, I would like to end my talk with the famous African proverbs. If you want to go fast, maybe go alone. But if you want to go far, we have to go together. So South-South regional cooperations partnership is critically important for the country to keep the pace with the rapid advancement in technology and the data science, progress toward development and delivery of effective forecast for the climate resilient development, also for the disasters preparedness for the region. So thank you very much.
Thank you, sir. We just have one more talk. I request Dr. KJ Ramesh, former DG of IMD, and he is now representing the RHYMES collaboration. So I request him to talk a few minutes.
Respected Secretary MOS and other invited dignitaries, it is a great opportunity to interact with a different hat. Now I am advising RHYMES, that is Regional Integrated Multi-Hazard Early Warning Systems, located in Asian Institute of Technology campus in Bangkok. So RHYMES has been guided by successive secretaries of MOES as the RHYMES Council Chair. 22 countries service climate and extreme weather services are rendered by RHYMES on need basis by different national meteorological and hydrological services. And currently the RIMES Council is headed by Dr. Ravichandran. He guides annually the kind of activities to be built. So now RIMES is implementing a program called South Asian Hydromet Forum, where different training and service delivery enhancement programs are implemented for last 3 years by the World Bank initiative. And there is another data set which is prepared is Regional Resilient Data Analytics System. Apart from integrating that, basically addresses the climate change variabilities and trends at a different country scale with very fine resolution downscaled IPCC ER6 forecasts. And now there is a plan to integrate the data exchange platform where all the forecasts and observations of the region are pulled in, and sharing of different digital NWP products, not only from NCMRWF but from IMD 3 kilometers forecast is shared. And several decision support tools are built and customized at country levels using these digital forecasts. And there is a plan to integrate a DataX platform where digital forecast products are accessible to users along with the regional resilient data analytics system. And now with UK Met Office support, Wiser South Asia program is also implemented by RIMES for the region. And there is CRUISE, that means Climate Resilient Early Warning System for South Asia, is also under planning, finalization for implementing for the South Asian Hydromet Forum countries. So there is common similarities, and additional support systems need to be integrated between the activities of BCWC and the IMD, NCMRWF and IITM digital products with the resilient data analytics to link decision support systems at the country level with user sector needs, customization built into it with socio-economic data, etc. So it is all taking advantage of all digital products available both from India and global centers, use them and identify them which one works for different parts of the South Asia, and build and customize the decision support tools. In this endeavor, we continue to seek support of MOS institutions, particularly for ocean products INCOIS, for atmospheric science products from NCMRWF and IMD. And in times to come, we need to build customized decision support tools addressing the needs of the user community and the public in general. We are very grateful to the support of MOS institutions in building various activities for South Asian region. Thank you very much.
Thank you, sir. Thank you everyone for your patience. So we now break for lunch, and quick lunch. We'll assemble back at 2:45. We'll try to assemble back at 2:45 for the panel discussions. Thank you. I request all the delegates to join for lunch in the canteen area.